Yeah, imagine you have a task before you, a task that says you should develop a neural network model that would predict if a client's loan request will be approved or declined. And then in addition to that, you'll have your data set that you will use to train your neural network model. And this data set has got the loan ID, age, education, proof submitted. You also have loan amount disbursed previously, and you also have the asset cost. So asset of your client. You have number of loans. So request, previous request, and then you also have number of current loans, and then you have the classification column. So this column says either 0, which means your loan is approved, or the loan is declined. So let's take, for example, this person. This person is 27 years, and then you have the education here, which says 1. So 1 might be undergrad, and then 2 might be postgrad. So this guy has got an undergrad degree, and then we have the loan disbursed previously. And then this client's asset cost is this, and then they had approved 2 loans for this guy, and then 2 loans. We also have 2 current loans, and based on these features, the guy's loan was approved, which is 0. And then you can see a client. This client is 30 years of age, has an postgrad degree. This had been disbursed previously. The client's asset is this, and no previous loan, and then no current loan. And then this guy's request is turned down. You can see now, which is 1. So this data set we're going to be using. And then, so this would serve as input to our model. So 1, 2, 3, 4, 5, 6, 7. That would serve as input to our model. And then that input would interface with our architecture. So if you look at what you have here now, so we're supposed to have our input layer should be 7, but for this demonstration, we're going to be using just 2 neurons. So this should be 7. So our neural network has got 3 layers. We have the input layer, and so this is where the input, the client's request would go into, and that would interface with the W's in this section. And then you also have that interaction between W's here and the input being fed into layer 1. So layer 1 has got 3 neurons, and then that input to these neurons here would also interface with the W's here. And at the end, you have an output. So our output can either be 0, just like you find here. Our output can either be 0, which means the loan will be approved, 1, which means the loan will be declined, 0, which means the loan will be approved, and 1, which says the loan, or 1, which says the loan will be declined. I hope this makes sense. And then that interaction is captured here. So we have stage 1 interaction. And so your N1 and N2 will be the input. Yeah, so remember this should be 7 neurons, but for this sake, we're just going to be using 2 neurons to make our calculation easier. So we have the neurons, and then that neuron, the inputs to the neurons would interface with the W's here. So these are the W's in stage 1. We have W1, W2, W3, W4, W5, and W6. You can see the shape of this is what? A 3 by 2 array. 3 rows and 2 columns. And that would interface with the input to N1 and N2. And here you will do the calculation. You can see W1 times N1 plus W2 times N2. So this is your basic matrix multiplication. And then you will do W3 times N1, which is captured here, and then W4 times N2, which is captured here. And then lastly, you will do W5 times N1, and then W6 times N2. And you'll see shortly that W1, W2 are just values too. Values, and then inputs to that would you do your matrix multiplication, and then you get N3, N4, and N5. So this calculation, the result of this calculation would go into N3. The result of this calculation would go into N4. And it makes sense. You see that N1 flows, to N4 via this weight, and N2 is also attached to N4 via this weight, and that's what is captured here. I hope I'm right. Yeah, so you can see N4. So W3 times N1, and then you also have W4 times N2, and that goes into N4. And lastly, you have N5, and from this diagram, it makes sense. You can see N2 times N6 plus N1 times, N2 times W6 plus N1 times W5, and that goes into N5. So you have input to layer 1 now, and that input is also captured here. So you have N3, N4, N5 versus the weights here. So the inputs to N3, the inputs to N4, the input to N5 will also interface with W7, W8, and W9. And then that is captured here. So I hope this makes sense. So time to go to our Google Collaborate. We'll implement this shortly. So let's go to our Google Collaborate, and then I click on my folder. And yes, I had created lecture 6 earlier. So I'm going to click on it. So click on it, and then, yeah, so we'll be using the OOP concept. So you can also go through my video and my previous videos to check OOP. So we'll start with, so call it, say class, to create a class neural network. And remember, a class would have a default, a constructor. Constructor will bring, let's see. So we have, let's look at the diagram again. So we have the input number of, so let's see, number of neurons. So remember this layer, that's our input layer. So number of neurons at the input layer, that's what we are capturing. So we'll just say input layer, and then we also say number of neurons at the what? Number of neurons at layer 1. So how many neurons do you have at this layer? So that's what we are trying to. So we have, say, L1 at this layer 1. And lastly, we have number of neurons at layer 2. So we've captured that. And then let's try and, so we'll have self. Okay, so let's put tab. So about number of neurons here, number of neurons at the input layer, number of neurons at the at layer 1, and then the output layer, layer 2. So we've captured that. The next thing we need to capture is self dot. So we'll capture stage 1 weights. So look at your stage 1 weights. And then what this means is that we want to capture this. We need to capture this stage 1 weights. And this is the stage 1 weight we're trying to capture. And if you look at it, really, this stage 1 weight is what's the shape of this weight is a 3 by 2. And are we together? So if you look at it here, you can see a 3 by 2 stage 1, which means if you have 3 neurons, which means 3 rows, 1, 2, 3, and 2 columns. You can see now 1, 2, 3, 1, 2, 2, 3, and then number of neurons are the input layer 1, 2, 1, 2. So it reflects this. The number of rows reflects the number of neurons here, and then the number of columns reflects the number of what? Number of input, the number of neurons at the input layer. So we would go there and see. So this should be, so I'll put this here. So it should be like this, comma. So this is how it should be. Layer 1, and then layer 2 weights would look like this. I hope I'm right. So let's confirm if I'm right. Run it. Oh, okay, let's just take this out. So imagine, let's create an instance of this object. Let's say our loan prediction app. Let's say our loan predict is equals to. So let's try and create. You can see would pass in how many neurons you have at the input layer 2. How many neurons do you have at layer 1? 3. And how many neurons do you have at layer 2? 1. Can see. So 2 goes in here. 3 would also, yes, would also go into this, and 1 goes here. And then 2 is assigned to what? To the input layer, and then 3 is assigned to L1. You have 3 layers, 3 neurons, and then 1 is assigned to the output layer, which is 1. And then based on that, we can now let's import this. Let's import this one. So based on that, we can now set up our weights for stage 1. Remember, this is what? This is a 3 by 2 matrix. That's what we're setting up there. So we're setting this up using this random.randint, which means create random decimal values for 3 rows and 2 columns. Create a random decimal values for 1 row, I hope I'm right, and then 3 columns. So let's try and find the shape. Let's print the shape of this and see if we're right. So, okay, let's print this. Let's see this one. So this is an instance. Remember, I'm creating an instance from this class. You can see that's the class name. I'm creating an instance. This is an object. I'm creating an instance from this template. So, and then from this instance, I can access its property, isn't it? I can say, so let it print. So you see now, this reflects our weights for this. Let's put it here again. Let me minimize this one. And then you can see that's our stage 1 weights. You can see this is the value for W1, W2, W3, W4, W5, W6. So that's the weights here now. So that's what we have done here now. We've created the weights. And if you look at this as well, so you can see the weight for stage 2 is what? Look at stage 2 here. And then you have weight for, that's W7, W7, W8, W9. So you can see we've created our neural network, and then we've also created the weights. So W1. So these numbers are random values. And then during the training process, these W's will be fine-tuned. Remember, that's the objective of training your model. And then during the training process, the W's here, W1 up until W9 will be fine-tuned such that we're able to predict accurately. I hope this makes sense. Yeah, so we've created our class, our neural network, and then we've created an instance from that class. You can see, using the class name, we're able to say, okay, well, we want to create a neural network called non-predict that would have 2 neurons at the input layer, 3 neurons at layer 1, and 1 neuron at the output layer. And that's what we did here now. And then we also said that, okay, well, we also initialize the weights at stage 1. This is stage 1 here. Weight at stage 1. And then we also initialize the weights at stage 2 using this random.random. So it is just, so if I run this, you can see now it creates random values. So they are not static, they're random values. And then those random values will be fine-tuned over time. So the next thing we'll do is to what? So I'll take this out. And the next thing we'll do is that, so let's imagine that we have our input. So let's say our input looks like this. We're going to be using our NumPy.array. And then so let's imagine that, let's pick something. Let's imagine our 2 neurons reflect here this number of loans and then reflects number of current loans. So for this guy that is 27 years of age, so 2, we'll pick 2, and then come here and we would, I hope this is right, 2, and then you have 2. So that's our input to that model we've created. And then if I print the shape of this guy, so input dot shape. So let's print the shape of this guy. And it tells me that it's what? 2 rows, 1 column. So that's the input. And then if you look at what we have here too, you can see the inputs to N1 and N2. You can see 2 rows, row 1, row 2, and 1 column. So that's what we did here. So that's our input. So this is our N1 and N2. So we can see input. You can see input N1 to neuron N1 and neuron N2. So that's our input to him. So that's our input. And then we also have, so we have, let's say input to input. So what do you call this one now? Input to layer 1. Remember, to layer 1. If I go back here, you can see now this interaction, the inputs to N1 and N2 would interface with the W's here, and then that would also serve as an input. As the inputs to N3, N4, N5. So input to layer 1. So input to layer 1 would be what? You have NumPy dot matrix multiplication. So we have a matrix multiplication, and then you have yeah, so it's right. So let's see now. So you can see we're doing a matrix multiplication, stage 1 weights multiplied by inputs. And that's what we implemented here. You can see. Let's take this one down. So look at what I implemented here now. This is what I implemented. You can see our weights. So I'm doing matrix multiplication. Our stage 1 weights, you can see stage 1. These are the weights to stage 1. And then doing our matrix multiplication with the inputs to this one, N1 and N2. That's N1 and N2. And then let's print the output. So let's say print. We'll print this guy, and let's see what we have. Are we right? What happened here? So let's print this guy. Print. So let's print. You can see now. So this, it's like the input to what? The input to N3. This is the input to N4 and input to N5. So we'll just say, yeah, input to L1, and then, so that's layer 1, and layer 1 has got neuron N3, N4, and N5. So this is input to N3 for layer 1, input to N4 for layer 1, and then input to, am I right? Yeah, N5 and layer 1. So we're done with the first leg, and then what's next now? So input to L1, and then what we'll now do is this input to L1 will now be fed into this, the second stage. You can see now, so we use our second stage, and we'll do our matrix multiplication, and then we'll find the output. So we'll now do input to layer 2 becomes so you do a NumPy dot matrix multiplication, much more. And then remember how this would work out. You have, you have your weights, W7, W8, W8, and W9 captured here, here at stage 2. So it becomes loan. So I come here and say, let's come in that loan dot stage 2 weights would have to go with the input to L1. I hope this makes sense. And then we have the output. So let's print this one. Let's see the output here. So let's run it. So you can see now this is the output at, this is what goes into, this is what goes into N6, and then you have an output. So here you can see the output here says 4.051. And you can see if I run this again, you can see it also give, you can see. So this gave a different value. It says output is 0.69, which is very close to 1. So let's run it again, let's see. So why is this happening? It's happening because the weights here, so let's you can see we have random values being generated for the weights. The weight at stage 1, and then the weight at stage 2. We have random weights. You see random weights, and the task before us will be to fine-tune these weights such that the output reflects reality. So we've not added our activation function, and we'll do that in our next class. I hope this is helpful, and I would also put this. I'll put the code out. So thank you very much, and I'll see you in the next class.